Hello everyone, welcome back to Story Chronicles. In today's lesson, we are going to explore one of the most powerful network troubleshooting tools in Linux, the Traceroute command. Traceroute. If you're learning networking, preparing for certification, or working in DevOps or system administration, understanding Traceroute is absolutely essential. It helps you answer the critical responses. How does my traffic reach to the destination? So let's break down each step by step. But before we get started, please like, share, subscribe to my channel. So what is Traceroute? Traceroute is a network diagnostic utility used to track the path that packets takes from your machine to a destination servers. So it shows every router along the path or every hop, the IP address or hostname of each hop, the round trip time RTT for each step. Each line in the output represents one hop. This makes Traceroute extremely useful for troubleshooting latency, identifying routing problems, detecting packet loss, and finding where connectivity breaks. On many Linux distributions, Traceroute is not installed by default. On Ubuntu or Debian system, you can install by using sudo apt install Traceroute. Let's check if in our system exists Traceroute. So Traceroute don't exist. Let's install sudo apt install Traceroute. Enter. After installation, you're ready to use it. So basic syntax of Traceroute: trace, route, options, and destination. Let's bring example: trace route google.com. This command traces the route to Google and display each hop along the path. So the output shows the hop number here, the router IP, the response time, usual 3 probes per hop. 1, 2, 3. This is end destination. This is the most common way to use Traceroute. So it passes along the way 13 hops until the reach to destination. Let's bring some options which uses which Traceroute, the -4 option. So Traceroute -4 google.com. These options forces Traceroute to use only IPv4 protocol. Uses when troubleshooting IPv4 connectivity in dual stack environments. You can also use Traceroute -6. This option forces IPv6 usage. So essentially in IPv6 only if IPv6 preferred networks. Ctrl+C, clear X. Other option, -F. The -F option prevents fragmentation by setting don't fragment df bit in the IP header. This is very useful for diagnostic MTU related issue. So what is a fragmentation? Since we just use -F option, let's clearly understand what is fragmentation. Fragmentation happens when IP packet larger than maximum transmission unit, MTU. If packet is too large, it must either to split into smaller fragments or dropped if fragmentation is not lowered. Different networks have different MTU sizes. For example, Ethernet by default have MTU size 1500 bytes. GRE tunnels reduce effective MTU. IPsec adds overbit. MPLS network adds label. If your packet exceeds the smallest MTU along the path, fragmentation occurs. Why fragmentation can be a problem? Because fragmentation may cause increased latency, higher CPU load on routers, packet loss if fragments are dropped. Application performance degradation. Some firewalls block fragmented packets entirely. So let's use -F option, google.com. The packet is marked don't fragment. The router cannot forward it without fragmenting. It will drop the packet, send back an asynchronous fragmentation needed message, This helps diagnose path MTU issue. Other traceroute option, traceroute minus lowercase f 10 google.com. Minus f option says the start TTL value. This allows you to skip early hops to focus on specific segment of the road. You can set maximum number of hops, trace road minus m5 google.com. Default maximum TTL is 30. This is useful when you suspect the issues within the first few routers. We can disable DNS resolution, traceroute minus n google.com. The -10 option disable hostname resolution. So, benefits of that: faster results, avoid DNS lookup delays, displays only IP addresses, very common in real world troubleshooting. You can also traceroute to specific port, traceroute minus P 443 to google.com. So this is useful when testing firewall filtering behavior. You can also set packet length, for example, Ctrl+C, traceroute google.com 100. By default, traceroute uses 60-byte packets. Here we use 100-byte packets, useful for testing MTU behavior. Other option, traceroute --L. Display usage and available option for traceroute. You can see all options here. So how actually traceroute works? Traceroute uses TTL, time to leave field in IP packets. In the step 1, it discovers first hop, packet sent with TTL value 1. First router reduces TTL to 0 and drops it and send back ICMP time exceeded. ICMP time exceeded. So now first hop is identified. On the step 2, packet sets with TTL value equal to 2. It passes one hop, expires at second hop. And now second hop is identified. TTL increases step by step until the packet reaches the destination. When reach the destination, the server responds with destination unreachable message. That's how traceroute knows it reached the end. So traceroute command is a powerful network diagnostic tool that revolves routing paths, detect bottlenecks, identifies failure, help troubleshoot latency. If this video helped you, like the video, subscribe for more Linux and networking tutorials. See you in the next lesson.